All right, in order to simplify this radical, and because it's a larger number, what I'm going to do is I'm going to find the prime factorization of this number. And I do this with a number tree. There's a couple different ways of finding the prime factorization, but what I'm going to do is I'm going to find factor pairs that multiply to be the numbers above them, and I'm always going to just branch down with that. How you do that is you just got to first find a number that can divide this number. I know 3,375 can be divided by 5 because it ends in a 5. So I'm going to divide it by 5, and I get that it would be 5 times 675. And I'm just going to repeat that now with these numbers that are not prime. So 5 is a prime number. I'm not going to divide that at all. But I am the 675. I'm going to divide that by 5 again. And I get 5 times 135. And then I'm going to divide 135 by 5. And I get 5 times 27. And then 5 I can't divide, but 27 I can break up. I can divide it by 3. So I'm going to divide that to be 3 times 9. And then 9 I'm going to divide here and get 3 times 3. All right, and so what that means is that 3,375 is 5 times 5 times 5 times 3 times 3 times 3. So in other words, this expression would turn into, so this expression of negative 3,375. I'm going to do actually the same step as I'm going to separate this negative 1 part. So I got negative 1 times 3 to the third times 5 to the third. Why this is super useful is now what I get to do is I take this number, I wrote it in this prime factorization, and now I can treat each of these number parts just like I did with variables, right? So I can simplify these parts. I want to separate this 5 to the cubed and 3 cubed and 5 cubed into the parts that are going to work well with the radical and the square root and the parts that don't. So I got this negative 1 times 3 squared times 3 times 5 squared times 5. All right, and now comes the big work. I'm going to take the square root of the stuff that's going to work nicely and leave the stuff in the radical that doesn't work nicely. And so what I'm going to do is I'm going to take the square root of this 5 squared, which just would give me a 5, and the 3 squared. Again, just dividing these exponents by the index here of 2 that we don't see but is there with the square root. And the only other trick is, and this is the new thing that's been added to the mix, is the square root of this negative 1 will give us an I. All right, and so what we'll get is a 3 and a 5 on the outside and an I for those 3 parts that I can take the square root of, and what's left underneath here is the 3 and the 5, or I'll just write a 15 right here. Final step in cleaning things up, what I'll get is 15i square root of 15. So again, the big work is this. I'm going to take this number of 3,375. I'm breaking it up into its prime factorization here. And now I'm just going to treat each of these factors as they would with variables. I'm looking for exponents that can be divisible by the index, in this case the index of 2. And then down here I'm splitting them up into the parts where I can get exponents that are divisible by 2 by this leftover. The stuff that's going to work nicely gets square rooted. And the stuff that doesn't work nicely will stay under the radical, in this case the 3 and the 5. So 15i square root of 15.